I'm going to keep going. All right. Number 5. So to find the p-value, that is the area associated with your test statistic. We just found our test statistic to be a t-value equal to 4.00. So that's somewhere 1, 2, 3, 4 steps up from the mean. And a p-value is going to be the likelihood we see that results or something more extreme. But more extreme is dictated by our alternative hypothesis, which in our case was mu is greater than 27. So if you recall from our previous graph, when we were talking about the critical value, we were talking about left, right, or two-tailed. Well, with an alternative of mu greater than 27, we are a right-tailed test. Well, when we come and talk about the p-value is going to be in the same way, analyze that as the alpha was. Is it left-tailed, right-tailed, or two-tailed? Well, it's going to be right-tailed because that alternative being greater than 27. So this right here is our p-value that we're trying to find. And calculation-wise, we are essentially finding the probability that we see a t-score greater than or equal to this 4. All right, so using our handy-dandy calculator, this would be a t-CDF in this case. Let me get my calculator to show you this guy. Clear that out. Okay, so we're doing second distribution, going down to t-CDF. And the lower, in this case, if you see, is going to be our 4. Our upper, we're trying to quantify infinity, so 10 to the 99. And our degrees of freedom all along has been 5. And I'm going to write this out while it's... So 4 is our lower bound, upper bound, 10 to the 99th. And degrees of freedom is 5. And our calculator says we get something... Okay, it's still waiting for me to push enter. 0.00516 about. So percentage-wise, that's like roughly 0.5%, a little bit more than 0.5%. Okay, and what we just found is our p-value. The last step, most important. With a p-value of 0.516%, 0.5% roughly, are we going to reject or fail to reject? We said that if our p-value is low, HO's got to go. So our our p-value being low, we should say lower than what? Well, in this case, our alpha of 5%. So is 0.5% less than 5%? Yes, it is. So we are going to reject HO and accept H1, HA, our alternative, at, we set a 5% level of significance. Because our p-value equal to 0.516% was less than 5%, which was our alpha. Alternatively, you could have said that your test statistic, which was equal to 4, was greater than 2.015, which was your critical value. Okay? So in conclusion, thinking back to our original problem, do we have strong evidence that the new model was better miles per gallon than the previous? Yes. So therefore, the new model has better miles per gallon, I'll say fuel efficiency, than the old model, previous model. Okay, that's not how you spell previous. On average. I really hope y'all find this to be a good use of your time watching this video. I will upload pretty much everything. Let me know how I can help.